Pharmacological Society, founded in 1931. We're a membership society that supports a world in which pharmacology and therapeutics drive science, medicine, and healthcare for the benefit of society. Our staff team of about 25 now work exclusively with members and pharmacology experts, teachers, engagers, doctors, clinicians, regulators. We have a membership of just over 4,000 across the world who we work in collaborative with to develop projects and drive things forward. The society has a variety of outputs which all fit within our strategic plan, one of which is publishing. We famously have the British Journal of Pharmacology, British Journal of Clinical Pharmacology, and Pharmacology Research and Perspectives as three of our journals, which help share research, which then obviously grows the pharmacology community. We run a series of meetings online and in person. We run an annual meeting of over 1,000 people. We're also currently in the process of developing a World Congress in Pharmacology in collaboration with IUFAR, which is going to be hosted in Glasgow in July 2023. And we also host a series of focused meetings for different community types, of which I'm very much interested in the education and teaching focus, as well as delivering training on certain topics. We support early career pharmacologists through our charitable objectives. And as I've said, my role is very much to focus on the role of education and future generations of pharmacologists. And I guess across our endeavors and our work, we can generate income through the membership, through our publishing, through our meetings, and that income as a charity ultimately goes towards our educational aims and our early career research grants, awards, and bursaries that we provide. So it's lovely to be involved in a community that works so well together across a series of activities, and we're able to reinvest that into the future generations. So now stepping into my role specifically and focusing on our education activities, our priority is grounded in research. And in 2026, we started a project to try to build a core pharmacology curriculum for sort of basic science pharmacology education. We went through a Delphi process using our committee, and we developed this curriculum, which was launched in 2026, which identified a series of statements of knowledge, skills, and attitudes, which were relevant to pharmacology. That curriculum has been used, and after a number of years, we felt it was right to review that curriculum and get feedback from the education community on how it was being used. And in 2021, actually during the lockdown of the pandemic in the UK, we turned to a series of online educator networking meetings and got feedback through those networking meetings in order to redevelop a curriculum to identify kind of gaps and areas for improvement. One of the core areas which fits so strongly with our strategy and our aims is to build an inclusive implementation of the undergraduate core pharmacology curriculum. And we've recently launched this summer a new version of the curriculum which includes inclusive pharmacology teaching concepts. We've also included learning outcomes, more specifically to add to the statements of the knowledge, skills and attitudes that we had, as well as example resources. And this was through feedback. We felt that the educator community really needed this because what you get with educators teaching in degree programs is they have strong skill sets in certain areas, but what you're looking for is breadth in teaching pharmacology. And so you have that excellent knowledge in some areas, and collaboration is the best way in order to get that breadth that you need for a full pharmacology teaching curriculum. And so as a result of that strengths and weaknesses that was identified in educators, these kind of resource sharing and development was seen as so important. But what was really good about this exercise and this research is we were able to obviously identify areas of strategic priority, things that were coming up very regularly in curriculum that were important, but also areas by sharing resources and collecting resources, areas where they were weaker, less resources available and content was weaker. So we were able to sort of focus our attentions on some of those areas. Just to be really clear then, the core pharmacology curriculum is probably obvious to many of you on the call. Pharmacokinetics, pharmacodynamics, and increasingly pharmacogenetics are absolutely core to a pharmacology career. But interestingly, and what we were identifying is things such as experimental design and some of those fundamentals, were not only important in pharmacology, but actually looking at wider curriculum outside of pharmacology. Now looking at the biosciences and the biomedical sciences became absolutely important for understanding, how diseases and drugs are progressed. And what we've identified is that the lab animals are used throughout biomedical research, but comprehensively and consistently, our students are they educated to interpret data from those animal studies in the right ways? And so other things like ethics and the principles of 3 Rs, such as replacement, reduction, and refinement, became quite important in the broadest pharmacology kind of learnings. And that's just to highlight experimental design has started to, in our sort of research and work, started to demonstrate itself as being an important area for us. So if we look back at where the BPS has therefore taken a new approach to our in vivo education, which is an aspect of our broader an aspect of our core pharmacology curriculum. So if we look at kind of historical knowledge of in vivo education, the focus of the society and others is to train graduates, undergraduates, master's students with pharmacology. And try to get them to have that experiential. So, resources, content, funding, grants to give students lab time and access to in vivo careers and in vivo education. But increasingly, and if you want to reach the broadest audience of biomedical students, that kind of knowledge of experimental of animal research and interpreting the data of animal research is perhaps more important than the experiential side of animal research itself, which would come from people progressing with their careers in PhDs and expressing an interest in animal skills, and not necessarily at the broadest point at sort of undergraduate and early graduate master's levels. The other thing about that kind of then and now point that I just want to highlight is, trying to maximize lab time and lab exposure is an expensive undertaking. Licenses for in vivo work become increasingly difficult to do in the education space and hard to justify. And actually, when talking on the ethics side of in vivo experiments, there is a valid question about the ethics of using animals in that educational space when there are viable alternatives. So that comes down to that kind of 3 Rs understanding. And so that kind of a broad base of experimental design knowledge, ethics, 3 Rs becomes quite an important thing in the broadest term. This fits really nicely with our understanding of an animal research curriculum, which we implemented in 2018, where we kind of broke down our understanding of the curriculum using the now interpretation of breaking a curriculum into core learning outcomes, which are expressed at the bottom of the slide there, and then experiential learning outcomes, which kind of fit more with that master's PhD level in the graduate space. And so we are now focusing on things that fit with core. And I would say at this point, it's not talking just about pharmacology, it's talking about very broad education in the biosciences, biomedical sciences. And again, I'm highlighting, even when you're talking about animal research, or if you're talking about core pharmacology curriculum, and to an extent medical curriculum in pharmacology and medicines development, this understanding of experimental design does keep cropping up as being such an important area. I guess anecdotally as well, it's also worth highlighting that, that as a publishing body, the Society is aware of many manuscripts being submitted to BJP and BJCP, where there's often a misunderstanding of experimental design at quite an early stage, even from quite senior scientists, which leads to a misunderstanding of results and delays in publishing manuscripts. And therefore, kind of experimental design is quite clear as being a sort of concept right through the thread and the core of our discipline that is important to support and develop. And so we've launched into a process of experimental design content to support educators and future generations of scientists being our core area of wanting to do more work. And so how do you go about that? And again, we've used our educator networking meetings to try to understand what would be the best way to support educators in a time of, COVID was at us, teaching was being flipped to online teaching, lectures were being recorded. A lot of practical classes were being turned to being online through simulations and digital resources. And so what we were trying to do is not excessively burden student or educator time in delivering their lectures and their interactions with students, but also delivering support. And so an online accessible, free to access resource through a platform was seen as being important, with learning outcomes, animation content that helps students learn, with formative multiple choice questions as being a really nice knowledge check and a way of building that knowledge. And what's nice about this approach is that this means that core degrees don't have to change their delivery modes and delivery methods, because this becomes added to student homework and added to people's learning, rather than something that's embedded directly into a course. The BPS was also nicely in a position to offer a resource via feedback through the fact that we have a platform already, which I guess is unique to our society and not true of other learned societies across the field. The BPS delivers what's called a prescribing safety assessment exam, which in the UK all medical students have to pass in order to demonstrate competency of prescribing before they become junior doctors in hospitals and the healthcare system. And so we have this platform that's delivered. And so my role was to use that existing platform and transition into new resources for basic pharmacology science. And that is what we did. And so we've started to build a series of resources for experimental design. We've launched blinding and experimental unit as two concepts of experimental design, and we continue to build more of a suite of experimental design resources. And this page is starting to show you, via the link to the BPS Assessment Hub, which can be easily Googled, you're presented with a login page, which you can just log into. Sign up's very simple. You just simply need an email and a name. And so what we know across our membership actually is that educators are kind of sharing this link through our educators are sharing this link through their courses to say, go here and find out more. Once you've logged in within the platform, you have to navigate through a series of e-learning resources, and we've collected the core pharmacology animal research ones towards the bottom of the platform, which is free to access, and they could be shown here like little buckets which you can click start on and begin the resource. There's a series of other e-learning resources, because like I said, the platform has been built for the prescribing safety assessment, which is for medical students, and so there is a series of clinical pharmacology and prescribing e-learning resources within there too. Some are free and some are paid for, which is part of the sort of platform access. But the role of this work, the experimental design resources, are all freely available. Once you've identified and found the experimental design resources, they both open up in a kind of structured way that you'd expect for classic e-learning. You're presented with some learning outcomes, and you're able to download and see a glossary, which is a lovely design document which offers hyperlinks to find out more about some of the prerequisite key concept words which you may or may not know about. So it works quite well at lots of different levels, from undergraduate, graduate, through to PhD and master's students. After the learning outcomes have been kind of assimilated and understood, you're presented with a flow to the e-learning. So you start off with watching an animation which shows you a kind of an experiment concept and provides you with some definitions. And basically through that 4-minute animation, it will talk you through all of the learning outcomes as expected. You then move through a series of formative multiple choice questions that step up in difficulty, that kind of effectively kind of step you up from undergraduate to graduate to PhD level of understanding of the content. And it's true that some of the more challenging questions at the end even challenge some of our educators on our committees as well. So it really does step up in terms of levels. On the animation page, we present this 4 minutes and 33-second video where you're presented with a problem. So two scientists are discussing. We've got Alex and Mo here presenting a case of misunderstanding of experimental design. So Alex is describing to Mo that they want to investigate a drug treatment for irritable bowel syndrome. And the plan of the experiment that Alex was presenting in this video is that he's misunderstood his experimental unit. He's planning on using one animal with 6 poo pellets for a treated and non-treated animal, and compare the weight difference between these pellets in order to find out the effectiveness of the drug treatment of the experiment. And obviously the animation then goes on to explain how there's a potential for misunderstanding a signal to noise ratio here, where the variability between animals, because the experimental unit is the animal, and that's the misunderstanding. The experimental unit is not the poo pellets. And so the variability between animals can give a greater noise ratio than just taking poo pellets from one animal. And it talks through that really nicely to ultimately arrive at an experiment that's flawed, and multiple choice questions to follow that can really drive home some of those points. Within the animation, we've uniquely identified a principle of what experimental unit is. And it's interesting, actually, through our collaborations with UAR, through NC3Rs and other organizations, there was no definitive definition of experimental unit before this resource created. So I guess that also drives home our kind of point for identifying this as an area of need for education research, because the experimental unit definition seems to sort of vary slightly. And actually, in some cases, our experts were saying, I don't even believe the definition to be true in some of the websites that we were finding. And so we've redefined a interpretation of experimental unit that fits in cases and is agreed between other organizations, not just ourselves. This slide is showing you the interpretation of the animation, how it works with the explanation of the misunderstanding. The key point, I guess, of the experiment here that's explained by Alex is the misunderstanding of experimental unit of the poo pellets versus the animals. And this slide nicely shows in the animation how you get a smaller signal to noise ratio if you're taking the poo pellets from one animal versus the variability you get between species by correctly identifying the animal as being an experimental unit, giving you a wider noise ratio and therefore less likely to identify a misunderstanding or a truthful reading of the experimental output. And the use of animation is a really nice way of kind of explaining fairly complicated concepts that would normally take quite a lot of text in a visual way that's kind of engaging for students to see. Once the animation's completed, there's some questions there to just confirm understanding of the learning objectives, and you eventually get through to the power of the platform ultimately, which is to deliver a series of formative multiple choice questions with feedback so that it becomes learning and formative in design rather than just scoring and identifying failure. This isn't a scored activity. This isn't an examined activity. This is purely a formative, have fun, learn as much as you can. And in fact, if you're really stuck, just say you can't do it and read the outcomes that helps you really drive home your learning. And this is an example where you're asked to identify the area that's not experimental unit derived in terms of misunderstanding an experiment. I'll just pause a little bit because some of you are probably reading it and trying to figure out the right answer for yourself. So here's an example of attempting the question incorrectly, and how that works for you. And you can see over on the right-hand side, the platform gives the ability to be able to retry the question so that you can have another attempt if you feel like you were close but wanted to have another go. But if you're completely overwhelmed and don't know, you can just give up and reveal the answer. Here is what happens if you click the reveal. So you're obviously presented with the answer of being, the researcher expectations subconsciously affects the results, and that, of course, we know is as a result of subjective bias, which is fixed by blinding an experiment, such that those kinds of unconscious biases don't affect the results of an experiment, whereas the other three are all related to experimental unit. And the feedback, in thorough feedback, kind of really shows if people are kind of stuck, kind of all the background to why that is the case. That's particularly useful when the questions get slightly more complicated. I picked a very easy example here, but when the questions become really more engulfed and in detail, and there's subtlety to the question in terms of kind of fish tanks and versus fish inside the tank and how they're fed, depending on whether it's the fish tank or the fish itself is becoming the experimental unit. So there's subtlety because there's two questions very similar about fish tanks, where one's the fish and the other's the fish tank as the experimental unit. And so there's some subtlety in there where the feedback becomes quite important because you could be easily tripped up. The aim of this slide is to simply demonstrate that the resource is about experimental unit, full stop. It's not about animal research per se, although we often have animal experiments as the examples. This is a really nice example in the question about how you can identify the experimental unit of an in vivo experiment. And interestingly, it comes up in the animation where you know, is it the culture of cells that's the experimental unit, or do you need to, you know, repeat your culture of cells in order to, you know, have new stocks of cultures of cells to truthfully rely on an experimental design? So there's some really nice concepts there coming through. And what we plan to do with future resources is to look more at the human clinical trials side of experimental design as well. So it's not going to stay just within preclinical work. This slide is our plans for the complete set of experimental design resources running through experiment types, which is what we're looking at the moment, block design work, sample size, statistical power, randomizing, etc., leading on to decision making. And we plan to put together a kind of experimental flow summary document that kind of builds on all of the resources once we've completed it. We're moving at a rate of about 2 resources per year at the moment. It takes about 6 months, roughly 6 months, 6 to 7 months to produce a resource, you know, title as it stands within this table. And this is my final slide. So thank you so much for listening. And just to say, of course, I'm presenting the slides here, but I'm absolutely just a BPS staff member. We do work collaboratively with all of our members, like I said at the start. And so the expertise and knowledge of various members, including many committees, and feedback through our early career group and undergraduate groups that have membership with us to really work through peer groups to develop this content's critical. But the brains are absolutely not me, and our Professor Claire Stanford, Dr. Jude Hall, and Professor Simon Bate, who are fairly famous. Some of you may know some of them. So Claire Stanford, of course, is heavily involved in our journals work and is expert in animal research. And Simon Bate is well known in the UK for being a leading voice of statistical analysis, and is a scientist at GlaxoSmithKline. Thank you very much for listening, and back over to the chairs, Soraya and Luciana. Thank you.
Thank you so much. Can you hear me?
Yes, exactly.
Yes. Sorry, I heard something else in the background. I wasn't sure if it was me or someone else. Thank you so much, Mr. Page, for this excellent talk. It's such an interesting platform. I had so many ideas of how it can be used. I have several questions for you, but we can talk about it a little bit later. So I would like to welcome our young investigators now. I cannot see Mr. José. Is he here? Do you know, Anthony?
José Brito.
José Brito. Unless he is using a different name, I don't see him among us. We can move on, and I would like to invite Tainá to give her presentation. Tainá, thank you very much for accepting our invitation and being with us.
Thank you so much. I will share my screen. Are you guys listening to me?
Yeah, we can hear you loud and clear.
Yes.
Thank you.
It's okay?
Yeah, we can see your screen.
Okay.
Maybe if you put slideshow, yeah.
Okay. So first of all, good afternoon. My name is Tainá Almia. I am a master's student at the São Paulo State University in Botucatu. And I would like to thank the SBEFT organization for the opportunity to present my study entitled Nebivolol Mitigates Endothelial Dysfunction in a Model of Preeclampsia. So preeclampsia, hypertensive disorders of pregnancy constitute one of the leading causes of maternal and perinatal mortality worldwide. And the most important of these disorders is preeclampsia, which affects around 2 and 8% of pregnancies globally, and 1.5 in Brazil. And according to American College of Obstetricians and Gynecologists, preeclampsia is a disorder of pregnancy associated with a new onset hypertension, which occurs most often after 20 weeks of gestation and frequently near term, combined with severe features and the presence or absence of proteinuria. And even with higher numbers of incidents of this disorder, we don't have there's no specific treatment for this, only antihypertensive use. So looking into the pathophysiology of the preeclampsia, we know that in a normal pregnancy,
Taina, excuse me, is it only me who cannot see your screen change, your slides changing, or is it not changing?
No, it's not
because
changing.
for me, I can see only your first slide.
You need to,
you need to share the other screen.
Oh gosh.
You need to share the actual presentation mode.
Okay, I will stop the share and try again. Okay.
Okay. And try to put in this small book at the bottom. If you see.
Yes, sorry, so sorry. I will share again as a reader. I don't know, it's better. I will change now.
Yeah,
now I can see it.
Now,
okay,
now
so
it's
sorry
going.
about it.
It's okay.
I will start again. Okay. So as I told you that even with higher incidence, even globally and in Brazil, there is no specific treatment for the disease, only antihypertensive use. And looking into the pathophysiology of this disorder, we know that in a normal pregnancy occurs is aspiral uterine remodeling, which enables an increase of delivery of the blood to the placenta and consequently to the fetus. However, in preeclampsia, there's a failed remodeling of these arteries, which decrease of delivery of the blood to the placenta, and consequently leading to a poorly perfused placenta, which release pro-inflammatory proteins to the mother's circulation, leading to endothelial cell dysfunction with no well-established treatment. And endothelial dysfunction in preeclampsia presents an important character, which is a decrease of nitric oxide bioavailability, which occurs among other factors by the uncoupling of eNOS, the enzyme that synthesizes nitric oxide, leading to a release of reactive oxygen species, and leading to host-induced endothelial damage and endothelial dysfunction. So in this scenario, nebivolol, it's a molecule that emerges as a molecule which exists in two isomers, D-nebivolol and L-nebivolol. D-nebivolol mostly is studied as an antihypertensive drug that acts in the heart as a beta-1 adrenergic receptor antagonist, leading to a decrease of chronotropy and inotropy, for example. And the second isomer, L-nebivolol, acts through the endothelium, being an agonist, a beta-3 adrenergic agonist. And looking more with details about L-nebivolol, we know that nebivolol acts through the endothelium, activating beta-3 adrenergic receptor as an agonist, and leading to enos activation and nitric oxide enhancement combined with a ROS reduction. So why it's important for us? Why it's relevant for us? We believe that we are giving a new look to a drug already known and extensively studied as an antihypertensive, and now we are focusing on the endothelial action of nebivolol in the nitric oxide pathway and how the molecule modulates biomarkers of endothelial dysfunction in preeclampsia. So the aim of the study was to evaluate the effect of nebivolol on the nitric oxide pathway in an in vitro model of preeclampsia and its relationship with biomarkers of endothelial dysfunction and oxidative stress. And for that, we incubated a pool of plasma to healthy and preeclamptic pregnant women, plus nebivolol, a beta-3 antagonist, and L-name, a NOS inhibitor, for 4 hours in endothelial cells. And we performed some assays to identify some important molecules, such as nitric oxide and nitrate levels, which is a subproduct of nitric oxide. And what we found was that in the preeclamptic group presents lower levels of nitric oxide and nitrate levels when compared with healthy pregnant women. On the other hand, nebivolol treatment was effective to increase these levels in both assays through enos and beta-3 adrenergic receptor dependent way, as we can identify in here when nebivolol was added with the enos inhibitor and when nebivolol was combined with beta-3 antagonist in both assays. Regarding HOS, we identify that preeclamptic group presents higher levels of HOS when compared with healthy pregnant women, and with nebivolol treatment was effective to decrease these levels. So in conclusion, our study suggests that nebivolol increases nitric oxide production through beta-3 adrenergic receptors and enos activation, and also modulates HOS release, attenuating endothelial dysfunction. And of course, the understanding of these mechanisms using this model may offer in the future alternatives for the management and possible treatment of the disease. And for this work, we have some perspectives for next steps. So we want to evaluate the beta adrenergic receptors family through RNA interference and how nebivolol interacts with it. We believe that the understanding of this family we will give you some light to understand the drug and a little bit more about our model. And the second one will be to perform assays to explore beta adrenergic receptors family using other antagonists. So we use only beta-3 antagonist, and we would like to use another beta-1 and beta-2 antagonists to understand how the drug interacts with our model. And to explore other receptors that nebivolol activates. As I showed previously in the image, nebivolol activates other receptors, and we want to investigate a little bit more about it in our model. To test nebivolol in a model of shear stress. Shear stress is a model that mimics the blood flow in the endothelium, and we believe it's really important to understand in this model, not only in a static model that we use. And we believe that some collaborations, it's really important for us. We will use nebivolol in clinical trials in pregnant women with preeclampsia, and nebivolol in an animal model using a RUP model of preeclampsia. So we believe that all these next steps and some perspectives will help us to understand a little bit more about the nebivolol. And of course, I would like to thank my lab group from Department of Biophysics and Pharmacology, especially my advisor, Valeria Cristina Sandrin, and financial support of FAPESP. Thank you so much.
Very good. Thank you, Tainá. Shall we ask if Brito is around or not? Maybe he forgot. Something happened. It's very strange. Anyway, shall we see?
I don't see him either here, or I think if he were around, even using a different name, he would have let us know already. So
yeah,
perhaps we can move on to the discussion.
Yes. Sure. There are a lot of questions, so you can start if you want.
We had several questions here. I had a question for Alissa, and Newton Camargo also had a question for Alissa. She answered both the questions in the chat. But Alissa, would you like to say anything else? Or Newton, do you have any other, do you want to ask something else? Let's see here.
Yeah, if I answered the question sufficiently in the chat, I'm fine. But if there were other parts of the questions that I missed, I'm happy to elaborate.
I think he's okay. He just answered that he's okay. Thank you, Alissa. Let's see if we have another question here. Jack, you have a comment. Do you want to expand on this comment? Do you want to use the microphone and expand a little bit more?
Sure. So I enjoyed your study on the nebivolol. So we've studied propranolol, and propranolol is really interesting because it's used to treat hemangiomas of infancy. And we discovered that our propranolol, which is not a beta blocker, has no activity on adrenergic receptors, seems to have the predominant activity and is active in vivo. And one of the things I wanted to bring up is the possibility is whether nebivolol, which has some structural similarity to propranolol, could be affecting endothelial cells in a non-adrenergic receptor method.
Thank you for the question. I don't know. I'm really early in my studies. I guess I need to study a little bit more about it, about not only the beta adrenergic family, but I guess alpha as well, because I already read about some agonists. I don't know, some mirabegron. I don't know if you heard about it. It's a molecule already, it's a agonist. So I would like to study more, not only the beta family, but of course the alpha, and use some others antagonists of the adrenergic receptors.
Yeah, so it may be that the endothelial cells in preeclampsia are glycolytic, and we've shown that our propranolol can convert it to respiration, and it may be that you can do that without affecting the receptors at all.
Yes, sure. We need to we could combine the molecules. I don't know, or just inhibit some receptor and add propranolol.
Right. Okay.
Thank you so much.
Right. Welcome.
I just read the messages on the side saying that Brito has a problem with the internet. He can join us in 5 minutes. Let's see how we carry on, because we have a time until 3 o'clock. We need to finish the session. So let's see. Mariana, thanks to let us know. Yes, so I have a question for me. Just when you say about that you have the inclusive implementation, I didn't quite understand. What is exactly, sorry, they decide to
I can hear. Yes, the inclusive implementation's a really nice new piece to the curriculum that we're trying to introduce. And I guess this has come from a strategic view that we're trying to be more inclusive as a society across all that we do. And the education curriculum is just one way that we've tried to see that. It's difficult for any society to dictate how universities want to run their curriculum and their content. And so this is a guidance document rather than a mandate. But what we're trying to do here is kind of present an idea that curriculum in the UK, it may be so elsewhere, but certainly in the UK can be kind of taught in quite a Western approach to drug discovery, that you run a high throughput screen, you develop receptors that link to diseases, and you use different methods of assays and animal models that have varying degrees of validation against the disease area, and you develop medicines this way. And yet it's well known that in other countries that drug discovery happens through natural products, through other methods. And so I guess it's recognizing within the degree process that there are other ways, natural products, herbal remedies, and other things that are relevant to pharmacology that should at least be considered in addition to the kind of Western approach to teaching. But it's also around language, and actually what we're trying to do with the inclusive principles document is start a question and build a bank. So it's not us saying, we've fixed this for you guys, go and use this document and delivering it. It's starting to ask questions. It's definitely an iterative process for us, where we're going to start to sort of talk about the way language is used in education and how that can be inclusive or uninclusive depending on different cultures. And so kind of, it's picking on certain words and certain types and certain meanings to make sure that we are truly inclusive of all different types. The other element of this is looking at pharmacology degree as a discipline, and our genders and ethnic backgrounds and ethnicities truly shown throughout the career pipeline, and actually pharmacology, we know, looks pretty good in the UK compared to some of the other STEM subjects in terms of equality, in terms of later on careers. But there's certainly not saying that pharmacology's got that solved, and so there's some quite broad, interesting things that we kind of do with our principles document here. That, like I say, we've definitely not solved everything, but we're asking some interesting questions and starting some bibliographies of alternative ways of sharing stuff and using language that just makes educators just think a little bit, and anything that's useful in that space. And the reality is, it's very clear over that document when you click on that curriculum link and see that document, is very clear that we're asking the community for feedback, and we'll build this content as we move forward with this inclusive approach. Does that answer? Is that the detail you were looking for? Does that answer your question?
Yeah. I was trying to make clear to me and perhaps to the audience. I'll just close my microphone if Luke can carry on, because they decide to switch on some machine here.
I mean, one of the particular examples where we've so one of the things that the society does do is we give out grants to educators that are prepared to run projects in collaboration with us. And one of the things that one of the projects that's really been working on is sort of pharmacokinetics, pharmacodynamics, and actually kind of clinical, interpretations of clinical trials. So there's lots of questions going on in the clinical space with our senior sort of clinical trial design workers to ask the question: is quite a lot of clinical trials in phase 1 are done with men only, right? Is that right? And COVID's even an example of this, where we weren't really sure how reliable the vaccine was in pregnant women, leading to pregnant women being nervous about wanting to take the COVID vaccine because of the unknown nature of the way the vaccine was developed. So there's lots of really interesting kind of inclusive gender splits with how we typically would run drug discovery that just raises that question.
That's fine. So can I just add some questions? The guy, he has Brito, he just said he's in the audience. Shall we have time to listen to him? What do you think, Luciana, and all the guests? Is it because there are some questions here as well. So Brito can just let us know how is your talk in 10 minutes for sure. Is you there, Brito?
Can you see me?
I can hear you. Yeah, we can.
Okay.
So no, yeah.
Let me just ask this question here, which is it's a question for Tainá. Did you use mirabegron in this study?
No, I didn't. I already read about mirabegron, because this molecule already is a agonist, a beta agonist, but I didn't use.
Okay, thank you. It was Amanda's question, so thank you for answering it. Soraya, I think we can hear José's presentation, right? I think we're ready for him. I don't see any other questions that were not answered. So
if you have any
are you
further
okay,
question,
José?
yeah. If anybody has any further question, can put in the chat, and then the speaker can answer. Yeah, I would have, but I'll leave Brito to present, and then
Me too. I have several.
we can write. We can write that. Thanks, Brito. Go on.
Okay. Can you see the presentations?
Yes, we can. Go ahead.
First, I would like to thank Evaluation Committee for having selected your abstract and oral presentation. The theme of this presentation is action of sedative dopamine in the rat white isolate. The sedative dopamine is a novel catecholamine that has been first identified by liquid chromatographic code to the mass spec as a basal release from umbilical vessels. The basal release of sedative dopamine in the tissues was inhibited when to this were treated with inhibitor of the nitric oxides, L-name, and when endothelium was mechanoremovable, it is important to implies the human umbilical vessel is not present innervation. The basal release cis dopamine was identified in vascular tissues. So aorta ring is from the tortoise carbonarius and the snake Pantherocultatus. The euthanasia with animals use the rats in concentration 5% isofran until 1 minute. The white light isolate fixed to hot metal in the 10 ml or above. This is like the factor of the inhibitor of the nitric oxide synthesis when they release the sedative dopamine by rat isolate height rate. The release of sedative dopamine was evaluated by liquid chromatographic standard mass expression. Panel A showed that pre-incubation the white atrial with the nitric oxide synthesis inhibitor L-name caused a significant reduction in the levels of sedative dopamine. Panel B showed the atria obtained from rats chronically treated with L-name also presents significant low basal release sedative dopamine. In this slide, we have evaluation the effect of the catecholamines on the atria rate. Panel A show that at the concentration of 0.1 picomole, this is neat dopamine. it's not provoking increased heart rate, but 1 picomole, 10 picomole, 100 picomole provoke increased heart rate. The panel B showed that noradrenaline at the concentration 1 and the 10 picomole did not affect the atrial frequency. Noradrenaline at the concentration 100 picomole caused significant increase in the rate. Please note the increase at the frequency induced by noradrenaline at the concentration dependence. Panel C showed that adrenaline at the concentration 1 and the 10 picomole did not affect in the atrial frequency. And the panel D showed that dopamine at the concentration of 100 picomole and the 1 nanomole did not affect the frequency. Dopamine at the concentration 10 nanomole caused a significant increase in the heart rate. In this slide, we have the evaluation the time course of the potential chronotoxic effect induced by catecholamines on the heart rate. As seen in the presence like 6 dopamine induce increase the heart rate at 1 picomole, where noradrenaline and adrenaline induce increase in the heart rate 100 picomole and the dopamine at 10 nanomole. As it showed the panel A effect to the remove noradrenaline, adrenaline, and dopamine from the organ bus, the atrial frequency reduced to the basal levels, but since the dopamine continued the increasing frequency thereafter. In panel F, we have evaluated the effect in intravenous single bolus injection of 1 picomole kilogram of sedative dopamine, noradrenaline, and adrenaline. The dose only sedative dopamine increase the heart rate frequency. Since the release of sedative dopamine is reduced by incubation of the atrial with the nitric oxide inhibitor LNAME, we have evaluated the effect LNAME in the atrial rate. Incubation of the atrial rate with 100 micromole LNAME caused a significant reduction of the atrial frequency, which was not seen when the right atrium was incubated with the LNAME. The atrial frequency as atrial obtained from animal concentrated LNAME was significantly low that obtained from control animal. Panel did that rat they are chronically treated with LNAME had significantly low heart rate comparado to control animal. This slide the effect of the beta blocker atenolol in the increase in the heart rate atrial induced by catecholamine. Panel B showed that atenolol at the concentration 100 nanomole provokes significantly increase the redução in the frequency heart rate. Please note the same nanomole atenolol had no effect to increase frequency dopamine, noradrenaline, and adrenaline, but reduce of increase frequency seismic dopamine. This slide shows that effect beta blocker beta-solol in the heart atrial rate in vivo. Panel A and panel B show that beta-solol 0.1 and 1 micromole induce concentration-dependent fall in the atrial rate. In panel C, it shows that beta-solol 1 micromole causes significant reduction of the atrial rate. However, it does not affect frequency in the atrial incubation with L-name. To that in panel B. Beta-solol 1 micromole also induce fall in atrial rate in ato obtido from animal chronic. Side effects in beta blocker metoprolol. This slide shows that incubation of the atria with tetrodotoxin did not affect basal release of the dopamine, indicating that basal release does not from nerves terminals. Our results demonstrate that seismic dopamine is the most potent endogenous mediator of chronotropism in the red isolated atria. However, unlike the classical catecholamine, seismic dopamine is not released from nerve terminals. That's when the beta block reduce the atrial frequency at the concentration that they only block the chronotropism affects the dopamine, which that they choose the right classical as dopamine antagonism of beta blocker. Thank you your attention. These are students involved in this particular project.
Thanks a lot, Brito. So I think people, if Luciana, if we have any question, we just have 3 minutes because I think we are exactly 3 o'clock and we have the final closing session for the meeting starting at 3. But I suppose if there is any question to address to Jack or Alice again, or even to the last talk, I think we have 3 minutes, so it will be the time to set up all the final slides, I suppose, for the closing session. Is there any question? I asked some for Jack, but I don't think he's so. Maybe he left. Is there any other question? Thanks a lot, Brito. Nice data. We have
let me ask something to another thing to Alisa, since we still have a minute. Alisa, I'm sure you have thought about using these nanoparticles for skin wounds. So I was wondering if you looked at the wounds, if you tried to apply these nanoparticles to fibroblasts, to keratinocytes, and if you looked at the migration of the cells in the presence of the nanoparticles.
Yeah, so thank you, Luciana. We have looked at migration of cells in the presence of the nanoparticles, and we do see slightly enhanced migration of both keratinocytes and fibroblasts. So we are hopeful that the nanoparticles will be useful for wound healing.
Thank you very much.
Is there any for Lee? Otherwise, I think for Brito. I just have one for the student. I know it would be a good treatment, but I was wondering about the security of beta blocker for the baby, because I know the beta blocker are not very secure for pregnant women, but I suppose, I don't know. Can you tell me something about?
It's for me. Yes, but it's really controversial in here in Botucatu, because we know some doctors that use beta-1 blockers to treat pregnant women, and this such as metoprolol and labetalol, and it's already used in the clinic, so could be controversial because nebivolol it's known as a beta-1 antagonist, and with vasodilating properties, and it's not used in here, and as we know from the other doctors. So yes, could be some way danger for the baby because the blood flow will decrease, but we know that some doctors use in here. So yeah, we need more studies to understand a little bit more about this relationship with pregnant women.
So Brito, you showed the new stuff for everyone, and it was very nice. So you're suggesting is a new modulator of heart and something similar to noradrenaline. Is that what you showed?
The synthesis dopamine is actually different from effectively the noradrenaline and the adrenaline, because synthesis dopamine not concentrate increase in heart rate, is a prolonged the effect in heart rate with out atria, but the classic catecholamine, if out the atria in organ buff, is not is returned to effect initial BPM.
Thank you. Well, I think if nobody has any more questions, I just want to thank you a lot, guys. Alisa, Lepage, Taina, Jose Brito, and also Jack that just left us, and of course my great colleague to be with me and to accept all the invitation to be with us. So,
thank you everybody for attending our symposium. It was very nice to have you all, and thank you to our speakers, and thank you to SBEF's organizing committee for accepting our symposium.
Exactly, it was very nice, and I was very happy. We had few people watching you guys, so very nice. Great pleasure to have you all here. So let's hope next year we'll be together in person.
In person, yes. Hopefully.
Right.
Thank you very much.
Thank you very much. Bye. I took a picture before people leave.
Professores, vocês vão querer ficar para comentar alguma coisa pós-evento?
Não, eu acho que não, né? Não tem nenhuma avaliação, nada de pôster. A gente vai para a sessão final. Você tem alguma coisa?
Já encerrou, né, a projeção?
Já, no caso, os participantes já estão na sala, mas aí no caso é só...
É já isso.
É só fechar a sala, é só fechar a sala.
Certo.
Tá bom? Ok, obrigado, professores.
Muito obrigada, Anthony, pelo suporte. Thank you very much, Alisa and Lee, for being with us. Thank you for the students. They had excellent presentations. Yes. And thank you for everybody who stayed with us in the symposium.
Yes, thank you to be here.
Soraya, thank you so much.
Luciana, parabéns.
Thank you, Joilson.
Oi, Joilson, tudo bom? Obrigada pela presença, Joilson.
Maravilha, hein? Que coisa boa aí, parabéns mesmo. Gostei bastante.
Obrigada. Entendi bastante. Tchau, beijo. Vou lá no final.
Tchau.
Tchau.